In this video, we will see some more example of complexity classes. As in previous video, we will discuss complexity classes in details. If you didn't see the previous video, so I want to say that or I suggest you to first go to complexity classes first video, then you come from this class, because we discuss in first video details of complexity classes. Now I will continue and give more example. Let's talk log and base 2 and log 3, log and base 3. Which is greater? Log and base 2 is greater or log and base 3 is greater? For to understand this, let's take one example. Log 100 base 2. If you find this, you can use calculator, because in any examination example get you have a calculator. Okay, its values will be 6 approximate, and if you take log 100 base 10, its value will be 2. So it is clearly we can understand that if base is greater, or then value will be less for same value. So here base is less, so log and base 2 is greater than log and base 3. It is mathematically. Now we need to discuss asymptotically. For that we will use one more logarithmic formula, that is log a base b. It will give log a base c log b base c. Okay. Now take log 3 base log and base 3. If we take c value as 2, then it's this is b and this is a. Here b value equal to 3 and a value equal to n for this example. Okay. Now and here we will take c value as 2. Then log a value is n and c value, we take c value as 2. Here log 2 and b value is, this is 3. Its value will be approximate 1.5, and okay, and ultimate log and by 1.5. and log 2 equal to log, here again we will take c value as 2. Okay. Then here a value equal to n and b value equal to 2, and c we will take as 2. Then its value will be log n and c is equal to 2. Here log 2, its value will be 1, and ultimate log 2 and by 1. Okay. Now it is clearly that difference is only constant, so we can write according to this mathematical description, we can write log n base 2 equal to theta of log 3n, log n base 3. And we can mention it that if difference is only constant, then we can write it. If difference is only constant, then we can write it. Okay. And if difference by only base, then we can write theta. And if theta is possible, then omega and big O also possible. Actually they are not mathematical equal, but asymptotically we can say that that will be the log n base 2 and log n base 3 is equivalent asymptotically. Okay. Next we will take next example. Let's take another example. To describe which is greater or which is lesser than or to compare two function, we use logarithmic. But using logarithmic always is not suggest, because without thinking or without using common, if you use log, then it will give wrong answer. Okay. Now if you take log directly, then its value will be n log 2 if we take base 2, and here log n 2 3. Okay. Then this is 1.5 and this is 1, then n equal to n. If we use log, then it will become equivalent, but this is not equivalent. We need to use we need to break and then we use, if possible we cut common part, and then we will discuss thing. Okay. You can write 1.5 to the power n and 2 to the power n. Okay. Then cut here 1 and here 1 is greater than 1 is lesser than 1.5 to the power n. Okay. Clearly it we can understand 2 to the power n equal to big O of 3 to the power n. That is right hand side is greater than left hand side. So we use big O. And don't apply log blindly. First try to cancel out some similar term. It is suggestible that try to cancel some similar term. Okay. Next we will next example will be remember one thing, that don't use log blindly and try to cancel out some similar term. Next we will take log n factorial and log n to the power n. It is nothing but n log n. Okay. Now we will discuss that which is greater or which is lesser, or the relation between this function and this function. that relation should be, and relation can be theta, omega or big O. Let's try to understand it. According to Stirling approximation, n factorial is equal to root 2 pi n into n by e to the power n. This is mathematically equal. So we will take, actually we discuss here asymptotically. So we can eliminate some common part, that is 2 pi. So ultimately we have n to by e to the power n. Now we will put this value in here. This is Stirling approximation. Remember it. Okay. Now take log root n by e to the power n. It is nothing but n to the power 1 by 2. Okay, then 1 by 2 log n plus log n by e to the power n. Okay, this n will come here 1 by 2, or you can directly use this term also here. If you use all these term, that is 2 pi n, then here value will be 2 pi n, 2 pi, because it is constant, you can eliminate here it 1 by 2. Here you can eliminate log n plus here n log n by e. Okay, now explore it more. Log n plus n log n plus n log e. Clearly this is grid. So we will take highest part from here, and that is log n and log n. So its value will be n log n using Stirling approximation. Ultimately here n log n and its value is also n log n. So we can write log n factorial equal to theta of log n to the power n. Okay, and if theta is possible, so omega is also possible, and big O is also possible. Okay, next and there is one more thing, that if theta possible, then small o and small omega is not possible, but big O and omega possible. Now let us take this example. Here nothing is common, so we will take log, and write one point, that if nothing is common, then apply log both side. Okay, now apply log both side. If we take log n to the power 1 by 2 log n. Okay, take here 1 by 2 log n, and here log n. Clearly this is constant and this is greater than this. Okay, now according to this we can write that actually here left hand side is greater than right hand side, so we can write log n to the power 1 by 2 equal to big O of log n. Okay, and to the power 1 by 2 is equal to omega, big omega of log n. Okay, none. Thank you, and if you have any confusion you can write on comment box. We will discuss more example in upcoming video, and we will now discuss some trigonometry function. Okay, thank you.